Hey everyone, so welcome to our next section on addition and subtraction. In the previous couple sections we've worked on simplifying and we've worked on multiplication and division, so this kind of can complete our order of operations part with our rational expressions. So rational expressions, for example, just in terms of real-world application, would be important in things like photography as well as electricity, and understanding things like telescopes, microscopes, and cameras. Our lens equation, for instance, can be used as 1 over f is equal to 1 over u plus 1 over v, where f is the focal length, u is the distance from the object to the lens, and v can be the distance of the image from the lens. So then the question then says, how could you simplify the expression on the right of the lens equation? And hopefully you remember from multiplying, from adding and subtracting fractions from before, where you would need to get a common denominator in order to do that. So that's kind of the similar approach that we're going to be taking today, is taking a look and adding fractions when we have common and uncommon denominators. So starting off, we just have our basic numbers, okay, just going through and adding and subtracting fractions. So I have 5 over 3 plus 7 over 3, 5 over 2 and 2 over 3, and 1 over 9 and 1 over 6. So just try each one quickly and come on back when you're ready. Alright, so 5 over 3 and 7 over 3, our denominators are the same, so I can keep my denominator there. 5 plus 7 gives me 12. And 12 divided by 3 gives me 4. So my first one would just be 4. In my second one here, I have 2 and 3, so I don't have a common denominator here, but I can make a common denominator, and so I'm looking for the first multiple that they share in common, the lowest common denominator. So between 2 and 3, the lowest common value here looks like it would be 6. And in order to get to 6, I need to take this 2 and multiply it by 3. Whatever I do to the bottom part, I need an equivalent ratio to set up. So that means I'm going to have to multiply the top by 3 as well. And the 3 on the second one, I need to multiply that by 2, which means the top part also gets multiplied by 2, which gives me 4. And so now that I have a common denominator, I can add them together. 15 plus 4 is 19 over my common denominator of 6. I could flip that into a mixed fraction, but I'm not going to worry about that right now. We're just going to simplify them through. In my last one, my common denominator between 9 and 6, again, I'm looking for my lowest one. There are many common multiples that they would share, but my lowest common denominator here would be 18. And so looking for 18 on the bottom, I'd have to multiply the 9 by the 2. So again, I'd take the same thing with the 1. And the 6 would have to get multiplied by 3 to make 18, so I'd have to multiply the top by 3 as well. So 2 and 3 would make 5 over 18. So just adding fractions with common and uncommon denominators. So in general, to add or subtract rational expressions, then there's a procedure that we can tend to follow, where in case 1, if the denominators are the same, we can just add the expressions together and we're finished. We keep the denominator the same, we combine the numerators and simplify it where we need to. In case 2, where the denominators are different, we need to write equivalent fractions that set up the same denominator, and then we can use case 1 and combine them together. So, for instance, using equivalent fractions to set it up, if we were to look at this first expression or this first equation, 10 over 3x minus 12 minus 3 over x minus 4, I would have no idea how to create a common denominator for that if we didn't simplify this out. So, it's very important for us to be able to reduce these out to see where we could go. So, for instance, in the first one, 3x minus 12, I do see that I can simplify that. I can factor out a 3, and then I'd have x minus 4. And so on my next part, I've got 3 over x minus 4, and do we see how the x minus 4 show up in the denominator on both of them? So what's missing? Well, the second one is missing a 3. And then whatever I do to the bottom, I do to the top, and then I could start to simplify this expression. So I could combine it into one term. I'd have 10 minus 9 on the top. And then I could simplify my expression and come up with my non-permissible values like we've been doing from before. So we can kind of see where this is heading, right? We're going to come up with addition and subtraction expressions that we're going to have to factor and simplify, and then state these non-permissible values. So there's a couple of them that are here to start with. I'd like for you to pause the video, try them out, and see how you do. Really do this for kind of all of them as we start to move through, is to try all the questions out, and then if you get stuck, you can certainly, kind of skim through the video portion of it and kind of catch up to the point where you think you're stuck, or watch it in its entirety, or even skip to the end to check and see if you have the right answer for each section. So I'll just leave that kind of up to you and how you feel best to proceed through it. So in our first case, we kind of have a couple, that first problem is like a case 1 scenario, so the denominators are the same. So in this case, I can really just leave this over 5, and then I combine my top, x plus 3. Done. There are no restrictions because I have nothing in the denominator that's a variable. In the second question, now I have 6 and 9, and I need to make something that's in common. And again, from the previous problem, we figured this was 18. So something plus something, we know we're going to have 18 on the bottom of each one. 6 times 3 gives me 18, which means I need to multiply this by 3. So I'm going to have a 3x on the top. And then times 2 for 9 gives me 18. So times 2 here, 2x times 2 is 4x. So what does that give me in the end? 7x over 18. And again, I can't simplify that any further, so I'm done right there. Moving into these monomial denominators. So I have 3 over a minus 2 over b. So I need to come up with a common expression for each one of them. I need them to be the same in the denominator spot. So what is each term missing? Well, it's missing the other one. So the a is missing a b, and the b term is missing an a. So really, I would like this to be over a times b for each one. So how do I get there? Well, I need to multiply the a times a b, which means I need to do the same for the top. So I've got 3b. And the b expression is missing an a, so I need to multiply an a on the top and bottom as well. And that makes 2a. Now notice the only reason why I can do this is because I can work backwards. Remember, a divided by a cancels each other out, which would just get me back to 2 over b. So that's the only reason why this works, is because I'm using an equivalent fraction. I'm using the same thing on the top and bottom because I can cancel them out if I needed to. So now I have the same expression, same denominator, so then I can rewrite this out as 3b minus 2a all over ab. Now, I do have variables in the denominator here, so my conditions on this would basically be to look here along my equation and to see, okay, what can my values not equal to give me 0? So a and b cannot equal 0, right? That would be my restriction that I would have in place on this question, right? With my final expression, or my simplified expression, being that 3b minus 2a. So in my next example, I have things that are over x terms, and you notice that there's an x in each one of them, so that's good. I don't need to add an x in anywhere. But my numbers aren't the same. So between 5, 4, and 10, I need a lowest common denominator, the first multiple that I can think of that would come in common with all of them. And as I start thinking through the 3 numbers, really the 20 is the number that pops into my head. So again, I would make these over 20x for each one of them. 20x, and another minus sign, and 20x. And so what am I doing to get to 20x for each term? So 5x times something gives me 20x, so that's times 4. And then I know I need to multiply my 4 times 4, that'll give me 16. 4x to get to 20, I have to multiply it by 5. So I know multiply this by 5 and I get 15. And then 10 needs to be multiplied by 2, so multiply by 2 on the 1. I get 2 here. And then when I take a look at all of the different expressions for these, I have 16 minus 15 minus 2 over 20x. So that's just going to give me a value 16 minus 15 is 1. 1 minus 2 is negative 1 over 20x. Okay, so there's my simplified solution, where I know that in all of my question that I've worked out with the different steps, x cannot equal 0. Alright, so taking a look at the next one, for example 3. So now we have an AB, an A, and a B. What's there? And again, I have to go through the same process here and try to figure out, okay, what needs to be in each one. So to start with, I would like to come up with what the common expression is that I can use to help me figure this out. So, oh, and I wrote the things on the bottom by accident. So, what would they be in terms of figuring out their values? So I have, it looks like there's an A and a B in each one, so I'm going to need an AB term to show up in each expression, okay? AB and AB. Now what about the numbers 4, 3, and 2? So the lowest common multiple between them, if I start looking or skip counting by 4s, by 3s, and by 2s, looks like I'm going to run into 12 as a value before they all overlap. So I'll have 12AB, 12AB, and 12AB. That's my lowest common denominator for each term. So now I need to look and see, okay, what do I need to do to make each value an equivalent ratio over that 12AB? Well, what did I do the first term to get to 12AB? I had to multiply it by 3, because I already had an A and a B. So multiply by 3 on the top, and I get 15. The 3A, it had to be multiplied by a 4 and a B to get there, right? 3 times 4 is 12, A times B is AB. So the top part needs to be multiplied by a 4B as well. So that'll give me an 8B on the top for that one. In my next one, I've got 3 over 2B, so that looks like it needs to be multiplied by a 6. 6 times 2 gives me 12, and as well as an A, so 6A. So 3 times 6 gives me 18, and I've got 18A as a value. So now that I have the same denominator for each one, I just combine my terms together. 15 minus 8B plus 18A, all over 12AB. Simplify this expression a little bit more, and actually looking at it, sorry, I guess I thought I could subtract the numbers. I have a B term in one, I have an A term in the other, and I have a term with no letters in it. I can't take this any further. I'm done. Between 15, 8, and 8, there's nothing I can factor out. So this right here would be my simplified solution, where now I start to look for non-permissible values. So the values that I get that cannot equal 0, looks like A and B cannot be 0 anywhere through that equation, because it would just give me an error or an undefined value. So let's take a look at our next example. And again, I encourage you to pause and try the questions as we get to them. It'll help your understanding if you're kind of trying them out too and running through these, just so you can kind of get a handle on what to do. So in each of these ones now, I don't have any variables on the bottom, which is kind of nice. That means I'm not going to have any restrictions, but I do have terms that I need to be able to combine. So 6, 4, and 2. We actually did a problem similar already, and we know that the lowest common value here is going to be 12. So I'm going to have something over 12 plus something over 12 minus something over 12. Now how do I get there? Well, 6 times 2. So up here, when we times by 2, remember that multiplies everything. Same thing with the 4 and with the 2. So here really I have 2 and then 2x minus 1. The 4 is going to have to multiply by 3, and so I'm going to have to multiply this by 3, and I'm going to have 3x plus 1. And then in my last one, I'm going to have to multiply this by 6, which means this is going to have to get multiplied by 6, and I'm going to have 6, 2x minus 5. So notice that I'm creating brackets around those terms on the top, because I know the number that I multiply on the top when I create my equivalent fraction is going to have to multiply each of those terms. It's going to have to multiply basically each expression that's on the top. So now that I have something over 12, I can essentially create a common denominator. Okay, so I'm not going to expand the brackets just yet. I'm just going to write out what I have, and we're going to take a look and evaluate it from there. So all of my expressions in the numerator, and we know that they're all over 12. So in my next part, now I'm going to expand what this top part looks like. 4x minus 2, so just taking 2 times 2x and 2 times negative 1, plus 9x plus 3, right? 3 times 3x, 3 times 1, minus 12x plus 30. So after that, all over 12, my next step then would be to combine my like terms together. So I'm going to go through and combine all of my x terms together. Looks like I have a 4x and a 9x and a minus 12x. So 4 and 9 make 13. 13 minus 12 is 1. So I actually just have an x term. Then I'm going to take a look for my next value, my numbers. I've got a minus 2. I have a plus 3, so there's positive 1. And I have a 30. So it looks like in this one that I'm going to end up getting a, minus 2 plus 3 is positive 1, plus 30 is positive 31 over 12. And then I start to identify some of the restrictions that I have. So some of these restrictions are taking a look at the bottom part. Actually, they're all numbers, so I have no restrictions here. So this is just my final answer right there. Okay, so there's a couple different examples there where we need to run through and see how things kind of work in terms of simplifying your expressions and then seeing if there's any non-permissible values. So I'm going to pause this one here and we'll pick it up on the second spot.